We'll turn it back over to you, Stephanie and Ross, for our keynote.
Great, thank you. And what an exciting morning. I just, once again, the resources, the knowledge, how we've elevated from just recycling all the way up the zero waste hierarchy and really implementing it. And this is our newest R, Retransforming. I had the pleasure of meeting actually Donald Thompson, who is the CEO of CDRC, at in Costa Rica this summer, and was just overwhelmed by his enthusiasm and really the integrity of what they're doing with their new Resin 8 and the work they're doing globally and making sure that, you know, the resources are getting closed loop first, and then we have this retransforming, and they didn't want to call it recycling. They wanted to call it transforming. So I encourage to add the RE in front of it. So in place of Dawn, we have Ross Gibby, who is the COO, the Chief Operating Officer of the Center for Regenerative Design and Collaboration. And he's going to talk about his program and also let us know why Dawn isn't here. This is just an amazing organization and just elevating what they're doing to the business level that they are, the global level, and at the same time, making sure it's working locally and benefiting local communities. So we can do the next slide over to Ross's bio and look at that. And then Ross is going to go ahead and share his screen. And we will be joining together again next week in Costa Rica for the Zero Waste International Alliance Conference. You can join virtually or in person, so we hope to see you there. Ross, I'll let you go ahead and share your screen and take it away. Thank you so much.
Great, thank you very much, Stephanie. I'm going to assume at this point that you can hear me. Is that true?
Yeah.
Okay, great. Excellent. Thank you, Stephanie. And as I share my screen here, let me just mention that Donald Thompson does send his apologies for not being able to make the event today. He was called into New York City to present to the board of directors, to one of our partners, the Alliance to End Plastic Waste, and bring them up to speed on a lot of the recent progress and plant openings that we've had both in Costa Rica and the United States. He's also making an announcement about a second generation product that we have that's just being announced today, and the press release went out earlier this morning about a technology that not only absorbs and sequesters plastic waste, but also absorbs and sequesters CO2 in the process. So essentially we're using non-valuable plastic waste as a filter to absorb and sequester CO2 in concrete. So I'll go into that in a little bit in my presentation, but again, Don sends his apologies for not being here today. So we are CRDC Global. Our mission, and what we actually like to call our call to action, is to create appreciating value from the world's plastic waste. And when I say world's plastic waste, we actually mean it, because our process can accept all 7 resin types. Resins 1 through 7, you know, the triangle on the bottom of a plastic packaging, you know, the number inside, we can take all 7 resin types, and we can take contaminated, mixed polymers, etc. But I'm actually getting ahead of myself. A lot of those resin types are not recycled at this point. So they have or are considered low or no value. And we're actually converting them into a material, a building material for concrete, which not only does it provide value to the concrete itself, but when it goes into buildings, let's say affordable housing projects or commercial buildings, those structures actually appreciate in value over time. So we're taking a waste stream that currently has low or no value, and we're converting it into something that not only has value in the present, but will appreciate in value in the future. And when we do that, not only are we creating an environmental benefit by diverting massive quantities of plastic waste from landfill or from incineration through, waste to energy or even informal burning. Not only are we creating that environmental benefit, we're also creating the economic benefits all along that value chain, providing jobs, providing businesses like the concrete companies, like construction companies, profitable ways to take advantage of this waste stream. And that also provides social value. We are actually converting plastic waste in a local geographic region. So we're taking a waste stream from a very specific region. We are converting it into that waste stream. I'm seeing an annotation on my screen here. And we're actually helping to build those local communities themselves. So we're building the infrastructure. So everything is very, very much closed loop. The plastic is being converted in a specific region and then going into concrete products and construction projects that are also in that region. So we are providing environmental, economic, and social value. I've lost a little bit of, there we go. So everyone here is probably very, very well acquainted with some of these numbers. A very small amount of plastic waste is actually being recycled worldwide. Greenpeace recently came out with a report that indicated it was only 5%. Numbers were hovering somewhere between 9 and 10% for a while. The recycling industry is indicating that it's much higher than that. It's all up for debate, but the bottom line is a huge percentage is still not being recycled. And of that 90% that is not being recycled, considerable amount is ending up in landfill in the oceans, and a lot of it is unfortunately ending up in the environment in the form of CO2 through these waste energy facilities or these informal burning. And worst case, it's ending up in the oceans or the rivers through leakage into the environment. So the issue is obviously massive. That's why we're all here today. And what we have is a scalable solution. What you see on the left side there is actually a pile of Resin 8. We call it a lightweight eco aggregate. An aggregate is actually just commonly rock or sands or any mineral component that goes into a concrete product. So concrete is essentially made of cement, which is the powder, which is when hydrated, it's like the glue. It's the bonding agent in a concrete product. And then the rest is pretty much aggregates and waters. And what's very different about our product, or a huge differentiator from, let's say, mechanical recycling, is that we can accept all resin types. And we also don't need to segment any of those resin types. And we also don't need to clean any of those resin types. So we take multi-layer polymers, we take mixed plastic waste, we take dirty plastic waste, plastic that's been in the ocean for 10 years, collected off of beaches, out of rivers. It may have organic like slime or algae associated with it. If it came out of a municipal waste stream and it has food associated with it, or if it has paper labels, we can accept all of that. So we're very flexible on the front end in terms of what we can accept. You name it. I mean, we're basically getting car bumpers, kayaks, plastic lawn chairs, etc. But we converted into this material called Resin 8, which actually improves the performance of concrete products. So how does it improve the performance of concrete products? Our developer, Donald Thompson, our founder, CEO, and the developer of this technology, he came from the concrete industry. He came from the construction industry and knew that in order for, let's say, an aggregate made from plastic waste to be adopted at scale by the industry, which is the only way you're going to absorb the massive quantities of plastic waste. It would need to be adopted at scale. It couldn't just be landfill in disguise. We couldn't just be hiding plastic waste into concrete. It would not be accepted by the industry. People have been trying to put plastic into concrete for quite some time, probably about 10 years now. Unfortunately, plastic in its natural form is hydrophobic. it repels water. So it automatically repels cement when it goes into a concrete product. So it immediately lowers the strength and lowers the structural integrity. And so it would not be adopted at scale by the construction industry if it did not maintain strength, first and foremost. You might have some niche applications like, park benches or concrete countertops, but it had to maintain strength in order to get into all of those structural applications that are predominant in the concrete and the construction industry. So what Don did was go about creating a process that converted the natural form of plastic from being hydrophobic to being hydrophilic. In other words, cement would stick to it. And so how we did that was basically part of our process. We take the plastic waste, we don't wash it at all. So it has a much lower carbon footprint than mechanical recycling because we don't send it through a washing process. We also don't have any wastewater as a result of that. We shred it, we granulate it into about quarter inch flakes. And then we mix that with a couple mineral additives. Those mineral additives are hydrated lime or just powdered lime. Calcium hydroxide is the technical term for that, and ash is the other one, a pozzolan. And we use varying types of ash depending on the country that we're in, but we mix that all together, the plastic waste and the two powdered mineral components, and we run it through an extrusion process. An extruder is basically used currently to recycle plastic waste. If you're recycling PET or HDPE, those uniform waste streams, an extruder is used. It's basically a big long barrel with a screw running through it and heaters on the outside. So it pushes the plastic through that barrel, it melts it. And what happens is it changes form. First of all, it doesn't change anything chemically, at least not to the plastic. It just melts it and mixes in those mineral additives. And what we do is we add a little moisture to that mixture. And that moisture actually creates steam in the barrel of the extruder. And that steam then acts as a blowing agent. And so when it comes out the end of the barrel itself, it expands like a cheese puff. And it creates this open cell structure. And these big chunks of cheese puffs, they drop into a cooling bath and they harden. And essentially what they exactly look like, is basically plastic lava rock. It has that open cell structure that you see there in the magnification. That open cell structure is what allows us to maintain and in some cases increase strength in a concrete product. We granulate those big chunks of plastic lava rock into the exact same gradation of construction sand or fine aggregates. So it's from the very, very fine particles up to about a quarter-inch particles. But they all maintain this microscopic open cell structure. And what that open cell structure allows is for the cement paste to permeate into all those cavities. And when we granulate it, we get that irregularity and that angularity that allows for mechanical bonding to happen as well to the cement paste. So the cement paste permeates into all those little structures and completely encapsulates the particle. And when we also granulate it, we're exposing the calcium hydroxide, the lime, and the ash. And when we expose those particles, those are actually pre-existing in cement. Calcium hydroxide and pozzolans or ash are pre-existing in cement. So there's a chemical bond that happens there as well. So this is kind of the secret sauce on the concrete side, on the construction side, that allows us to maintain strength and provide that foundation for the construction industry. And as I mentioned, in certain concrete mix designs, we actually increase strength. But maintenance of appearance was another one that was critical. Don, coming from the industry himself, knew that it wouldn't be accepted if you had all these colorful little flecks of plastic in a concrete product. It had to look almost identical. And that's essentially what we've established as well. Going back to that pile of gray sand that you see on the left side, that's exactly what limestone screenings or construction sand looks like. So maintenance of appearance, you can't even tell the difference when this goes into a concrete product. And obviously maintenance of fire resistance was massive as well. Fire resistance is critical. And in fact, we've actually had tests that show improvements in fire resistance. But again, maintenance is what we talk about because it all depends on the actual mix design. But where we do get improvements and considerable value propositions from utilizing Resin 8 in concrete is reduction of weight. Our material is 1/4 of the weight by volume of sand of what it replaces. So that's considerable, either on a per unit basis or, even when we're shipping that concrete to the job site, we're seeing the ability to lower carbon footprints because of that reduction in weights. And obviously, it also helps with certain concrete product applications that require reduction of weight. Lowering of water absorption is another one which helps with durability of the concrete. It helps with longevity of the concrete. But also what's really exciting is that it improves insulation. Resin 8 is actually 3 times, it has an R value 3 times higher than sand, what it replaces. Now, we don't replace 1-to-1. We replace smaller percentages of that sand with Resin 8, but when it goes into a concrete product, what we've seen is it has improvements of about 20% of the R value. So when you put Resin 8, let's say concrete block, into a building, it actually reduces energy usage of that building over time. So here are a few examples of just the types of concrete products that we can go into. Again, it was mentioned all structural and non-structural concrete applications. What you see on the left side there are concrete blocks and paving stones. Those are considered dry mix concrete. There's a lot less water in those, and those are created by forms and vibration. In the middle is precast concrete. What you see there are drainage tubes that go underneath roadways. Those are used by one of our concrete partners in Cape Town, South Africa, where we have a small scale Resin 8 facility. And then you have poured in place or ready mix concrete, what we all know as like the big cement mix trucks that you see driving down the highway. So ready mix concrete as well is another application. And our new product that does have the carbon capture technology is much more applicable to ready mix, and I'll talk about that in a minute. So obviously we have these environmental benefits. We're diverting plastic from landfill and incineration. I mean, this is something because most MRFs, most material recovery facilities are really only focused on 1s and 2s. Occasionally, they're looking at 5s, polypropylene as well, but there's massive quantities of plastic that's not even being run through, municipal waste streams or recycling streams. That's currently just going directly into landfill. We're also reducing the energy usage of buildings over time. And one thing that a lot of people don't realize is that concrete is actually recyclable. At its end of life, let's say in an 80 to 100 years, when a building gets torn down, that concrete actually gets crushed up into rubble, and it will be reutilized as aggregate in the next version of concrete. So, what we're doing here is we're taking the plastic out of a recycling loop, out of a recycling stream, out of a plastic recycling stream, I should say, which may have, I don't know, an event horizon of 3 months or so. And the likelihood that something will go around 3 times is very, very small. In fact, less than 0.5%. And we're converting it. And as Stephanie said, we're transforming that plastic into a material that then goes into a concrete recycling loop, which has an event horizon of 50, 80, 100 years, and then can go on in perpetuity. So we're essentially giving this plastic waste an environmentally benign end of life solution. Our product can be used to gain lead points as well. Because of the use of recyclables. I know that we're kind of dancing around that term recycling. The reason that we don't use the term recycling, because in its strictest sense, recycling is basically plastic back into plastic. And what we're doing is converting it into this hybrid mineral polymer eco aggregate. But using, let's say, waste materials in new construction, you can gain lead points for it, and also reduction of the energy usage because of the increase in the R value. So I talked a little bit earlier about scalability. On the left side there, you see one of our newest commercial scale facility. That picture is a little bit out of date. We now have some nice signage on that building. That building in Costa Rica will be capable of processing about 4.5 tons per hour, 4.5 tons of resin 8 per hour, which is about 4 tons of plastic per hour. Costa Rica is about 5 million people, and that plant will be capable of absorbing the entire mismanaged plastic waste stream of the entire country of Costa Rica. Now, what you see on the right side is our plant, which we recently opened in York, Pennsylvania. That will be a little bit smaller. It's the footprint there looks, quite big, but our facility there will be capable of doing about 1.5 tons per hour. The reason being is in the United States, obviously the geographic area is much larger, and we see our plants being much more widely distributed around the country. I talked about it earlier. We don't want to be shipping plastic very far. We can actually get all the plastic we need in a very local geographic area. We'll convert it into that geographic area, and then we'll put it into concrete and construction projects in that area. So that'll be about 1.5 tons per hour. We're currently using that facility now. And the reason that we chose York, Pennsylvania is because we wanted to use it to seed the market. And essentially York has access to Baltimore and Washington, D.C. and Philadelphia and Pittsburgh and Harrisburg and all the other mid-sized cities in Pennsylvania and Delaware and New Jersey and New York City. So it's basically our pilot commercial facility in the United States, but we envision about 50 to 75 locations expanding across the U.S. And I should say that the Alliance to End Plastic Waste, where Don is right now in New York City, presenting to them, is our partner on these 2 facilities. But one thing I didn't talk about was scaling down. We can actually scale down to a relatively small size. We just had our machinery arrive on the island of Samoa, which has about 200,000 people. And so we can scale down to, let's say, these island countries, which have limited land, therefore limited landfill. The landfills are bursting at the seams. They're inheriting a lot of plastic because it's washing up on their beaches. In a lot of cases, island countries are tourist areas, so they have a lot of visitors that are producing waste. And they basically are in a no-win situation at this point. So a resin 8 solution and a resin 8 plant, which matches the population center, matches the waste stream, matches the demand for construction in that area, can be suited to that particular region. And we're seeing a lot of attention from the ocean conservation communities and from the island nations because of this. We're also moving forward on locations in Curacao, in Jamaica, Dominican Republic, the Philippines, Maui. So this has gotten a lot of traction because of its scalability and adaptability of our facilities. So this is a little bit of a roadmap or just a map of where we are currently. This is a little bit out of date as well. I was informed by Don yesterday that we're actually in development in about 25 countries. Right now, we have those 2 commercial facilities. We have about 6 small scale facilities, including Cape Town, South Africa, Hong Kong, the UK, Mexico, and Australia. And then we're in development in a whole lot of other countries. And on the right side there, you see some of our partners. Our partners really do run the gamut. I mentioned the ocean conservation groups. We work with a lot of nonprofits and NGOs that are doing the noble work of collecting plastic off of beaches and protecting our oceans. We'll take that plastic all day long. That's the Ocean Recovery Alliance, Howell Conservation Fund. But we do also work with the plastic producers. We're finding that they finally are starting to take responsibility for the end of life of their product. They will probably be mandated to do so in the future with EPRs, extended producer responsibilities. But we do work with Dow, we do work with Braskem, we do work with those groups in order to help them figure out how to have an environmentally friendly end of life to their plastic waste. But we also do work with construction companies. Pedregal is our largest partner in Costa Rica. They are the largest concrete and construction company there, virtually a monopoly. Martin & East is a construction company in South Africa. Georgia Pacific is actually our plastic waste manager and supplier in the United States. But we're also working with these big international organizations like the United Nations Development Program. They're actually taking the lead on our project in Samoa, and Habitat for Humanity. Most specifically, Habitat for Humanity, we've partnered with them to build 700 affordable homes in Costa Rica already, and that relationship is now expanding international. So what you see here is actually that first project in Costa Rica. On the left side is the affordable housing neighborhood that we started off with. This is actually quite an old picture as well. This neighborhood is fully established at this point. The dirt is now all grass. The street is covered with kids and cars, and it's fully developed. Again, we've built 700 homes in conjunction with Habitat there, with some support from Dow and obviously support from Pedregal, the concrete partner. And then on the right side there is actually our first commercial project in the United States. That's the Braskem Innovation and Technology Center in Pittsburgh. Our product can also go into asphalt. So we've talked a lot about concrete up to this point. When it goes into asphalt, it works a little different because it melts into asphalt, and therefore it acts less like an aggregate or, like a rock or a stone that acts as a filler, and more like the bitumen or the glue that holds the asphalt together. But what you see on the left side there is a test in Costa Rica. It's about a 4-kilometer test on the largest or the most traveled route in Costa Rica, which is Route 27 from San Jose to the coast. And that was in conjunction with a Spanish company called Global Via. Those tests have just recently concluded, and we've written, or I should say a third-party lab has written a white paper on those test results. So we are getting a lot more traction in asphalt as of late. However, concrete and building projects are our priority because, as I mentioned, we do prefer for the material to go into something that actually has appreciating value. So this is what I mentioned and alluded to earlier. A press release just came out this morning. Formal press release announcing this new technology. What this is we take the original core resonate particle, which does have that open cell structure, which kind of absorbs material. And we take that and we batter it with a cement paste and absorb it to an emission source. In certain cases, it's literally just an emission source out of a vehicle, a truck or a car. And it absorbs the CO2. The calcium hydroxide in the cement paste absorbs CO2 and converts it into calcium carbonate. Calcium carbonate is literally just limestone. So what happens is it creates a limestone shell around the outside of the core resonate particle. And we also add some nylon fiber reinforcement there. And we take that it's basically hot and active initially when the reaction happens with CO2. And we put that into ready-mix concrete, poured in place concrete, and it has incredible value. Not only does it accelerate curing through carbonation rather than hydration, but it increases strength. When it increases strength, it allows us to reduce the amount of cement used in that concrete mix. And you may know that cement has a very high carbon footprint, and it's also very expensive. So we can not only absorb and sequester CO2 with the particles themselves, but then we can use it to reduce the amount of cement used, which further reduces the carbon footprint. It also adds workability. That's incredibly crucial to poured in place or ready mix concrete. It has to flow into whatever form that it's being poured into. So workability is incredibly critical. And we also, it adds air entrainment. So real quick, I know I see Stephanie jumping up there. I got 1 minute. Okay, so real quick, 3 of our waste streams are industrial, environmental, municipal. The municipal waste stream is the most challenging for us because when our material comes to us from the MRF, all the clean stuff's been pulled out for recycling and it's the residual stuff. But unfortunately, the residuals are mixed in with the aluminum, the glass, the paper, etc. So it can't be extracted. So we've actually created our own collection and recovery program called the Bag That Builds. And it's super simple. All plastic goes into one bag and it will be zero waste. We guarantee none of that will end up in the environment. It won't go to landfill, it won't be burned, and it won't be leaked into the rivers or the oceans. And what we're able to do is actually pull some of those clean ones and twos out of that waste stream. We sell those back into a recycling loop. We run that revenue stream through a foundation, and then we donate that money towards, let's say, additional beach cleanups or additional river cleanups, or we pay towards transportation of the material to us. So the ones and twos get pulled out, generate a revenue stream that goes to foundational purposes, and the rest just flows right back into RESINate. This program has gotten wide acceptance in everywhere we are right now. The bags are being distributed through schools in Costa Rica and Samoa and Cape Town, South Africa. In the US, in York, Pennsylvania, they're being distributed through community organizations like the Rotary Club and the churches and the Garden Club and the Audubon Society and senior communities. And this is just kind of taken off. You see some of the pictures of the bags themselves. They're just being dropped off at our facilities. But people are going wild over this because of the simplicity of it and because we accept all plastic waste. And these are just a few pictures of our recent opening in York, Pennsylvania. That is our founder on the left side, Donald Thompson, making a speech in the ribbon cutting there. So that is the end of the presentation. And I will share.
Thank you, Ross. This is amazing. And I know when you were talking, we were saying, oh, just 15, 20 minutes. But there's so much, and this is so transformative. We have tons of questions in the chat. And what I would like to offer up to everybody, because we have another session starting, is that you go to Ross to their website and first do your research, read all about, like he said, they are not burning this plastic, they're transforming the plastic. And it's really multifaceted in what they're doing, how they're getting the materials, what they're doing with the materials, like you said, 1 and 2s, they're getting back into the recycling stream. And just having met with Don briefly in Costa Rica last time, he got his start, just like the rest of us, with plastic pollution in the ocean and in our rivers. So he knows more than anybody that we need to stop the flow of plastic. So this is not to undermine any of our reduction, reuse, closed loop, all of that. This is to help do it. And as he stated, it's like setting up 300,000 Starbucks franchises around the world, but to help to solve the plastic waste. So Ross, would you like to just a minute to close it up and let people know how they can contact you, how they can be involved? And then I will set up another webinar and send it out to this community so we can have a more in-depth discussion.
Sure, I will put my email address in the chat, and so you can send me a direct email. If you don't end up taking that down, you can go to our website, info@crdc.global. Will also make its way to me, and then we'll, please give 24 to 48 hours for us to be able to respond. As you can imagine, after having 2 recent plant openings in Costa Rica in June and in York, Pennsylvania in October, we are getting a lot of let's say inbound inquiries at this stage, and we are starting to build out our global team in order to address a lot of these opportunities and address our expansion plans. But right now we're kind of all wearing a lot of hats. So I appreciate if you're all patient, but we will get back to you, and we will answer all of your questions and hopefully have continued conversations about collaboration.
Most definitely. And thank you to your whole team. Thanks to Don for his leadership. And I'll work with Ross and Don to put together a webinar right at the first of the year, and we can have a robust discussion. And we will follow up with Ross and provide him with all the questions and comments in the chat. So thank you again, Ross. Congratulations. And for our audience, if you'd like to move into the concurrence, we have some really amazing speakers. And look forward to continuing. Thanks again, and we'll talk soon.
Thanks very much, Stephanie. Thank you, everyone.
Bye-bye.